Today we are going to go over chapter 2, differentiation. In the first lesson, we are going to go over the definition of differentiation and the tangent line. So there are two definitions of a derivative. So first, on the left, is the derivative of a function. So derivative of fx. So we write it as fx prime. So this is given by the limit h goes to 0, fx plus h minus fx over h. And instead of the limit, which we call the different quotient. And on the right, give us the derivative at one single point, f of a prime, derivative at point A. So everybody see the difference between the left and right. So this is given by limit h goes to 0, fa plus h minus fa over h. Slope. So there are two types of lines in calculus we are talking about. One is a secant line. If we go through 2 points on the graph, which we call the secant, and as these 2 points getting closer and closer, this line will become the tangent line. So how do we find the equation of the secant line and how to find the equation of the tangent line? Let's have a look. So if you look at example 1, find the derivative of a function and find the slope of the tangent line. So this example 1, we are using the definition to find the slope. In the future, you don't have to, you can take the derivative directly, okay? So fx plus h, you just replace x in the function, all the x in the function using x plus h. So you get x plus h squared minus 3 times x plus h plus 2. And then you simplify it. As h goes to 0, you plug h equals 0 in. After you simplify it, you get the derivative of a function is 2x minus 3. So the derivative of f4, just plug 4 in, you get 5. And the derivative at a point fa prime, use this definition to find f4 prime. So we do 4 plus h minus f4 over h. You see, we get the same answer. How do we find the slope and the equation of a tangent line at any single point? So tangent line, we can write slope and point form. Given point, x1, y1, and you take the derivative, you find the slope. That's the equation of the line. So there are two lines, tangent line and normal line. The relation between their slopes are negative reciprocal. So for example, 3. So given fx, how to find the tangent line and normal line at x equals 3? So first, you find the point. You plug x equals 3, find the y value. So this is our point. Next, you take the derivative and plug 3 in. You get negative 1 over 9. That's a slope. So you use the point slope formula. So after you get the slope, how do we find the slope of a normal line? So we use negative reciprocal. So negative of whatever you get here. So give us positive 9. So everything the same except the slope. The second lesson, basically we have to remember all the different derivatives. Okay, derivative, power rule, constant, and all the higher order derivatives too. So derivative of x to the n give us n times x to the n minus 1. Keep in mind n has to be a number. Derivative of constant give us 0. Example 1, 2, I think you guys can do it yourself. So same thing. Slope of the tangent line to the curve. We take the derivative directly. We don't have to use the definition. Point slope formula. So tangent line, normal line, same stuff. The derivative of trig functions. So sine give us cosine, cosine, negative sine. Tangent, secant squared, cotangent, negative cosecant squared. Secant give us secant tangent. And cosecant x give us negative cosecant times cotangent x. Based on the fundamental derivative of any given functions, we are going to introduce you one of the most important concepts. How do we use chain rule, combine chain rule with whatever we learned, the derivative of the functions, to solve the derivative of any given function. So for example, sine 8x, this is your sine u. So given y equals f of u here. So y prime will be given by f prime times u prime. This is what we call the chain rule. So you have to take the derivative of 8x, give us 8. That's from the chain rule. Derivative of x to the fourth, you have this term from the chain rule. Same thing, you can practice these problems and have a look. So given s of t is equal to this function, s of t is the end height, s0 is the initial height, v0 is the initial velocity, t is the time. So first, if you look at the picture here, I define my initial velocity. So because I drop from the top, so the initial velocity is 0. And the initial position, or the height, I call it s of 0. So I consider this level is 0. And I plug s of 2 in directly, give me negative 64. This negative means it's below my initial value. So the height of the building is 64. Example 6. Okay, you can have a look at example 6, very similar to example 5. Next lesson, product and quotient rule. So product rule, given f times g, when we take the derivative, f prime g plus g prime f. And the quotient rule, f over g, it's a little bit more complicated. F prime g minus g prime f over g squared, the denominator squared. So chain rule combined with product rule, quotient rule, and all the fundamental derivatives. So for example, given y equals f of x to the nth power, so this is your u now. You have to compare this function to the fundamental equations or functions we learned. So this is your u. When we take the derivative, it's n times u to the n minus 1 times u prime. Now u is f of x. This is the u. F of g of x. So g of x is u. So it's f prime times g, g prime, which is u prime. Same thing, 4x, f 4x prime times 4. This is a little bit confusing. So you just need to be very, very careful. Okay, and then you can practice example 1, 2, 3, 4 later. Implicit differentiation is also a very important topic. When we deal with implicit differentiation, okay, we are taking derivative with respect to x. Okay, we have to take the derivative with respect to x on both sides. Why we need implicit differentiation? Because sometimes it's very difficult to write y as a function of x. So you have y on the left side and all the x on the right. It's very difficult. So that's why we need implicit differentiation. For example 1, we take the derivative with respect to x on both sides. X squared gives us 2x. This part we have to use chain rule because y is a function of x. So take the derivative of x, give us 1. So y times 1 plus, keep x, take the derivative of y. Same thing, here you have to use chain rule because y is a function of x. So now you simplify it. This is our answer. Same thing. Okay, after we find the derivative, we can ask you what's the tangent line, what's the normal line, and what's the second derivative. So you have to take the derivative again. So everybody try example 1, 2, and 3. You don't have to do example 4. This is some of the questions from chapter 2. So this type of problem is very popular. Given a table, how do you use the secant line to approximate the tangent line? Examples here tells us how do we find the derivative using the definition. For example, you have to realize this is the definition of the derivative. So basically on the left side, we are looking for the derivative cosine, give us what? Negative sign. Sometimes it's not that obvious. For example, example 2, limit h goes to 0, 3 plus h to the fourth minus 81 over h. Sometimes you have to figure out what is your function exactly. So it's fx plus h minus fx over h, right? So fx in this case, we are going to write something to the fourth power. So 81 equals 3 to the fourth. In this case, we can write fx as x to the fourth. So this is the derivative, basically derivative of x to the fourth at x equals 3, because a value here is 3, right? A plus h minus f of a.